All right, I mean, as long as you have those points in there, whether you've made the graph or not, you can still find the equation. You don't have to draw the graph, like you don't have to get it to generate the graph in order to find the equation. Last time what we did is put in the points and then right away find the equation. Here we made a graph first, but it's still the same. As long as under edit, that's the list of points we're looking at. You can go and do stat over to calc, down to linear regression, and it'll give you the equation that best fits those lines, those points. So it's going to tell you that. I'm going to, again, put this over here so we can write on it. So we'll be back in a second here. Where'd it go? Uh-oh. Let's try that again. So we got a slope of 1.006, and we have a y-intercept of, I mean, this isn't going to make any sense, but we have a y-intercept of negative 17. The slope is probably the more interesting thing here. Remember on our graph we had games played down here, and what did we have up on the vertical axis? What was there? Points, right? And we had a bunch of points, and then presumably there's some, we're drawing the line through it. I don't know why I'm trying to draw it by hand when I could just copy it here. I'll go back to the graph. What we're going to get it to do is try and draw the line of best fit through there. We've just calculated what the equation of the line of best fit is. But what we want the calculator to do is try and draw some kind of a line through here. That might be it. It might be lower. That would be too steep. That would not be steep enough. It'll draw the line that best fits those points. This is the equation over here. Okay, that line over there, this equation. But don't forget what you're doing is just trying to get it to give you an overall, what the overall relationship is. So if you're going to put that equation in, go to y equals and type it in. Okay, you can. I know that you didn't maybe copy it down, but it's up on the screen here. You can round it off. You have to. So basically, what you got to do is you got to put in ax plus b, except for substituted in. Right? So you're putting in ax plus b, but you're subbing in what it gave you for a, and you're subbing in what it gave you for b. There is a fast way to get it to do it, but I want you to do it by hand first. Then I'll show you, so you know what you're doing. So you're not putting in ax plus b, you're putting in y equals, and you can round it a bit, 1.006, I mean, even that's probably too much accuracy, plus negative 17.518 if you're rounding it off. Certainly that's enough accuracy for what we're doing here. Okay, so put that in under y equals 1.006x, don't forget the x, plus negative, you don't have to put plus negative, you could just put subtract, right? Plus negative is the same as writing subtract there, 17.518. Then when you graph it, you have the line that passes through. That's a bit higher than I would have guessed, but I guess there's 4 points up here and there's only 2 down there, so that's the closest it does. There's some players that are below the line. There's some that are above the line. What is the slope of this and the y-intercept? What does it represent? The slope, what does it represent? The slope is roughly 1.0, right? 1.0, what are the units on that? If this graph is games here and points here, what are the units on the slope? It's saying that you go over a certain number of games here, you go up a certain number of points. It's the same as what we used up here. I erased half of it, but it's points per game. 1 point per game, roughly. That's the average scoring for all the players we just put in, not just for the couple that we put at the top there. Okay, that's saying that's how much you can expect it to go up if you add on games. If you played a certain number more games, you could expect it to go up that many points each game. Okay, points per game. The Y-Intercept doesn't make a whole lot of sense in this case because it's negative 17. Based on the players that we have, if you worked your way backwards to 0 games, you'd score negative 17 points, which is obviously impossible. So I mean, this is not entirely, that number is not entirely useful, but the Y-Intercept is the starting value, what you would have at 0. All right? The 3 things that, are there any questions about that? No? The 3 situations that you have in this tutorial, the first one talks about boiling point and altitude. So you're given some different places. I'm not sure if you know this or not, but the higher up you go, your altitude, the higher up you go, the lower the temperature that water boils at. Like around here, water boils at 100 degrees. If you boil some water and it's bubbling away in the stove, if you put a thermometer in it, it's 100 degrees. If you went to Calgary, it would be about, water in Calgary boils at about 97, like the water boiling in the stove. If you put a thermometer in, it's not 100, it's 97. If you went to, not on here, but Colorado, I think it's like 92 or 93 because they're a lot higher. The higher up you go, the lower the temperature that it boils at. This is pretty high. It only boils at 80 degrees. So you're going to do a couple things here. You're going to make a graph by hand for this. And you're going to make a graph by calculator for this. I'm going to give you a hint for the scale because I have asked you to do this. This is a lot higher than the altitudes Mount Everest obviously is. This is a lot higher than the altitudes I gave you, so I wouldn't want you to set the graph up where you aren't able to plot this on there. So I'm going to tell you that the scale has to probably go up to 9,000 meters, and the temperatures have to go down to probably about 68 or something like that. 68. I think it's above. I think at the top of Mount Everest it's above 68, so that would be safe. The highest is 100, the lowest is 68. So what I'm saying is if you set this up so it goes from 0 to at least 900 and maybe goes from 68 to 100, whoops. That would be a good setup for that. Which one of these things do you think is the independent variable? Remember we talked about independent and dependent? The independent one sort of comes first. The independent one changes regardless of the other one. One of these is dependent on the other. Do you say that the altitude you're at depends on the boiling point of water? Or the boiling point of water depends on the altitude that you're at? Yeah, that way, right? The boiling point depends on the altitude. So this is independent. So it goes on the x-axis. This is dependent. So it goes on the y-axis. Sometimes it's hard to decide which is dependent on which. There's the 2 other situations I gave you. It might be a little harder to think about which is which. But you're going to set it up and do linear regression by hand. So when you're done, you should have some points on here. You should have a line. You should show a slope calculation the way we've done in the past. You should actually show what these are. Remember, don't just count squares. You actually have to see what it is on the scale. So this might be like 22 degrees Celsius, and this might be 4,500 meters. I'm totally making that up because it's not right. But you have to show that and then say what the slope is, what you're dividing to get the slope. Put the units. If you look at this, you can decide what the units are. The other 2 situations, one has to do with, this page is doing the same thing again, the Mount Everest stuff with the calculator. And then you're going to compare, okay? You're going to compare what you get here to what you got by hand. Okay, so you're doing that twice. And then there's 2 other situations here. Projector image. I got to pause this.